Hi kids, this is Teacher Ivy, your science teacher. So today we're going to talk about the first module in third quarter, effects of friction on the movement of the objects. Okay, so in this module, you will learn to infer how friction affects movements of different objects. So at the end of this video lesson, you are expected to be able to first define friction, second, identify the different types of friction, and third one is explain how the different types of friction affect the movement of objects. Okay, so before we're going to start talking about friction, let us first try to recall the things that you've learned in your previous grade about force and the different kinds of forces that affect the motion of an object. So let's recall these things by answering what's in. Okay. Directions. Read each question carefully. Write your answer on the blank before each item. Number 1. Roger pulls a rope attached to a stationary box. The box begins to move. Which of the following was exerted on the box that makes it move? Is it A, force, B, speed, C, velocity, or D, distance? Do you think is the answer? Okay, the correct answer is letter A. When you apply force to a stationary box, it will make it move. Let's have number 2. Force applied on an object can blank. 1. Change the amount of matter contained in an object. 2. Start an object moving. 3. Speed up or slow down a moving object. 4. Change the shape or size of an object. So what is the correct answer? Is it letter A, 1 only, B, 2 and 3, C, 1 and 4, D, 2, 3 and 4? Okay, the correct answer is letter B. If you apply force on an object, it can start an object moving or it can speed up or slow down a moving object. Number 3. Which of the following objects can be moved through the force of the wind as it blows on a fine weather? Is it A, dump truck, B, hanging clothes, C, building, or D, table? Alright, the correct answer is letter B, hanging clothes. Why? Because we are talking about a wind as it blows on a fine weather, so it is not strong enough to be able to move a dump truck, building, or a table. Number 4. In the game tug of war as shown below, what will most likely happen if there is an equal number of members in each team participating in the game? Is it A, the team with 3 members will have a stronger pull than the boy at the opposite side? B, the boy at the right side will have a stronger pull than the other team with 3 members? C, each team will exert equal opposite forces? Or letter D, the opposing forces of each team will cut the rope? What do you think will happen? Try to observe the picture. The other team has 3 members, the other one has only 1 member. Okay, the correct answer is letter A. The team with 3 members will have a stronger pull than the boy at the opposite side.
All right, for number 5. In which situation or situations is or are the forces on the objects balanced? Is it 1. A notebook resting on a table. 2. A rolling ball slowing down. 3. A mango fruit falling from the tree. Or 4. A parked car starting to run. So is it letter A, 1 only, B, 4 only, C, 1 and 3, D, 1, 3, and 4? What do you think is the correct answer? All right, so the correct answer is letter A, 1 only. Okay. Number 6. Which of the following situation shows that objects move through the force of water? Is it A. Twigs and branches from trees growing along the riverside reach to the sea? Letter B. A strong typhoon uprooted the big trees in the hills. Letter C. Ripe mango fruits fall off from the mango tree. Or letter D, girl pushing the cart in a grocery store. So what do you think is the correct answer? All right, the correct answer is letter A. Twigs and branches from trees growing along the riverside reach to the sea. So it is the force of the water that causes the twigs and branches to reach the sea. All right, number 7. When you place a magnet near the thumbtacks and needles, the thumbtacks and needles begin to move in the direction of the magnet until they are attracted to it. Why does this happen? Is it A, the magnet's opposite poles are attracted to each other? B, the magnet has the same properties to the thumbtacks and needles? C, the magnet, thumbtacks, and needles' metallic properties made them repel. Or letter D, magnetic force causes the magnet's attraction to iron-containing materials. Okay. What is the answer for number 7? All right, the correct answer is letter D. Magnetic force causes the magnet's attraction to iron-containing materials. Number 8. The pile of books on the table fall to the floor as Joshua accidentally hits the table while running after it's not her, it's his younger sister inside the house. Which of the following causes the movement of the table and the books? Is it A, force of Joshua's sister, B, force of Joshua towards the table, C, gravitational force of the earth, or letter D, air resistance? What do you think causes the books on the table to fall on the floor? All right, so the correct answer is letter B. It's Joshua's force towards the table that causes the books to fall. Number 9. A nail is attracted to a magnet. What force is responsible for this attraction? Is it A, electrical force, B, gravitational force, C, magnetic force, or D, nuclear force? Very easy. All right, so the answer for number 9 is, of course, letter C, magnetic force. Number 10, the last number for what's in, we have which of the following statements is true about forces and motion of objects? Is it A, Forces acting on the moving objects can either move them faster or slower. B. The change in position of objects can be observed without a reference point. C. Forces acting towards the direction of motion slows down the moving object. Or letter D. Greater forces applied on an object slows down its movement. What do you think is the correct answer? Which of the statements is true? All right, the correct answer for number 10 is forces acting on moving objects can either move them faster or slower. So we are now in What's New. Examine the activities shown in the pictures below. So we have here a boy playing on the slide and another boy playing with his roller skates. So I bet some of you experienced this already, these activities already. Now let's read. Are you fond of playing different games in your vacant time? Ganahan gid kay mo ani children. Do you enjoy sliding or skating in the playground as shown in the picture above? Did you have any difficulty in playing such games? Are your experiences in such activities the same in different places or surfaces? So, nangutana di anhi, did you have any difficulty in playing such games? O naabi mga times ganing slide ka, unya galisod kag abot sa ubos, or naglisod ka playing with your roller skates, no? So another question is, are your experiences in such activities the same in different places or surfaces? So the same ang imuhang na experience if you do this in different surfaces, like if you slide on a rough or smooth surface, or when you play with your roller skates in rough or smooth surface. So when you run, walk, play, and move from one place to another, there are certain forces that affect your rate of motion. When we say rate of motion, ang kakusgon sa atoang lihok. So may mga forces nga makaapekto sa kakusgon sa atoang lihok. So such forces have varying effects as they act on objects on different surfaces. In the picture above, or in the picture on the previous slide, you have noticed that the moving bodies are in direct contact with the surfaces of an area where they are moving. So katong bata nga nag-slide ka ganina, ang iyang body is in direct contact with the surface of the slide. And katupong bata nga nag-roller skate, playing with his roller skates, is also in direct contact with the surface, where he's skating. So contact force is responsible for most of the interactions we experience in daily life. Pushing a cart filled with goods or products in a grocery store, pulling a carabao while plowing the rice field, pushing a wheelbarrow filled with weeds removed from the garden on the muddy path towards the compost pit, transferring the location of chairs and tables in the classroom or at home, writing your name with a pen, or picking up a textbook from the table are examples of daily activities that make use of contact forces. In this lesson, we will investigate further on a contact force that affects the motion of objects. In the examples enumerated, friction plays a great role on why the rate of motion of objects
vary in rough and smooth surfaces. So we are now starting to talk about friction, the contact force that affects the movement of objects. So nganong lahi ang ato ang rate of motion or ang kakusgon sa ato ang lihok in rough and smooth surfaces. So naay dako nga role ang friction ana. So friction is the energy generated when two surfaces rub each other or objects have physical interaction with each other. Since two or more surfaces are in contact with each other, activities affected by frictional force often produce heat, especially if it is done continuously or for a longer period of time. So let's do this activity. Try rubbing your hands together and place your palms on your neck. Here, rub good. And then place it in your neck. So how do you feel? Okay, there you have it. That is an example of the effect of frictional force. We are now in what is it? Friction is a force that acts between two surfaces or objects that are moving or trying to move across each other. For example, when you try to bike on a rocky road, greater friction makes it more difficult to move the bike at a faster rate since it acts opposite to the direction of movement of the bike. As a result, movement of the bicycle slows down even if the biker applies the same amount of force as she strikes the pedals forward. So, have you tried riding or running a bike or a bicycle on a rough surface and on a smooth surface, children? So, lahi gyud ang rate of motion niya no, ang iyang kakusgon sa rough surface o sa smooth surface even if you are going to apply the same parehas nga amount of force, no? Okay. Let us try to understand more about friction by looking at this. Unsa gid ang friction? By looking at this picture above. So as you can see, the girl riding on her bicycle, no, nag-apply siya og force through striking her pedals padulong diri, no, iyang gi-apply nga force. So of course, kung apply ka og force going this direction, so the direction of motion is the same. Padulong pud siya diri. But look at the friction. Aha man siya padulong. So, it acts on the opposite direction of the movement. So, mao yun na ang nature sa friction. If you are going to the right, ang friction acts on the opposite. So, padulong siya sa left or vice versa. All surfaces create friction in an object moving across them in direct contact. Rough surfaces produce more friction than smooth surfaces. Hence, objects tend to move faster as they get in contact with smooth surfaces where there is less friction. So, tanan nga surfaces, whether it's rough or smooth, they all create friction. Pero, lahi-lahi lang siya. If you have a rough surface, there is greater friction. And if you have a smooth surface, naapoy less friction. That is why, di ba, kung smooth kay ang surface, we tend to move faster. So that is also the reason why if you have a very smooth floor, no, mahinay-hinay kita because there's a possibility for us na maslide ta. But if you have a rough surface, no, it has greater friction. So mas lisod i-move ang objects in rough surfaces. Okay, let us have types of friction.
So let's start with static friction. This exists between a stationary object or object at rest and the surface on which it is resting. It prevents the object from moving against the surface or changing its original position. So you have here a picture of a book on the top of the table. So static friction exists in this picture. So the book is not moving, it is at rest, it is fixed in one place. So there is static friction on the book and on the table. Now, in the illustration shown in this page, static friction prevents the book in falling from the table. No, it is the reason nga nung dili mahulog ang book. Ang static friction, ang reason nga nung dili mahulog ang book from the table. If you want to move the book from its original position, you need to overcome the static friction acting between the book and the table on where it is placed. So another example is, for example, the clothes, no, in your closet, it is resting, it is not moving, so there is static friction in that example. Okay, the next type is sliding friction. This occurs between two objects as they slide against each other. It is also known as kinetic friction. It is weaker than static friction. Writing with a pencil or pen on a piece of paper or notebook, a toy car sliding on an inclined desk, pushing a table on the floor, and pulling a loaded box on the pathway are just few examples where sliding friction affects the movement of objects. So from the word itself, slide, sliding friction. That's the second type of friction. Another type of friction is rolling friction. This acts on objects when they are rolling over a surface. Take note of the word rolling. It is much weaker than sliding friction or static friction. This explains why most forms of ground transportation use wheels, including bicycles, cars, four-wheelers, roller skates, scooters, and skateboards. This is evident in activities which involve moving objects with wheels or those that have circular or spherical shapes that can roll on surfaces, such as skateboards moving on a cemented pathway, rolling a ball on a hill or slope, running a car on the road, and pushing a grocery cart in the mall. So, another example, some of us, meron tayong stand fan na merong gulong, no? You have wheels sa tiil sa tuang mga stand fans or even sa furniture. So when we try to move these objects nga na ay mga ligid, may gulong, rolling friction exists in that activities. Look at the moving car traveling on the road as shown in the picture. Rolling friction generated between the car tires and the road as they continually get in contact will keep acting in opposite direction to the movement of the car, maintaining a speed that the driver desires. When the driver wants to stop the car, he or she steps on the brakes. The brakes apply force on the tires, causing friction to slow down and stop the motion of the tires. Okay, another type of friction is fluid friction. This type of friction acts on objects moving through a fluid. So a fluid is a substance that can flow and take the shape of its container. So fluids include liquids and gases. Have you tried pushing your open hand through the water in a tub or in a pail? Can you feel the resistance of the water against your hand as you splash the water in the container? How about playing a paper boat in a basin of water? Have you experienced this? Have you tried this, children? Can you feel the resistance of the water against your hand as you splash the water to move your paper boat at a distance? The same is true when you paddle a boat along the river or sea. The waves are current of water due to the fluid friction also exert force that is opposite to the direction of the movement of the boat. Hence, friction slows down the movement of objects until it stops at a certain distance or location. So even in fluids, fluids include um, water, liquids and gases. Even in fluids, there is still friction. Look at the skydiver in the figure below. He's falling towards the ground with a parachute. Resistance of the air against the parachute slows his descent. So the faster or larger a moving object is, the greater is the fluid friction resisting its motion. That's why there is greater air resistance against the parachute and the skydiver's body. So air resistance causing fluid friction acts in opposite direction to the downward motion of the parachute. All right, moving on, we are now in the next part of our module, which is what's more. It says here, study the given situation in each item. Identify the type of friction acting on the object or body in motion or at rest. Write either static friction, sliding friction, rolling friction, or fluid friction on the blank before each item. Do it now, children. Okay, for what I have learned, you are going to fill in the blank with the appropriate word or phrase that completes the meaning of each sentence in the given paragraphs. Select your answer in the list inside the box below. Okay, so do it now, children. Okay, for what I can do, study the picture in each item, then answer the question that follows. So we have the first picture is a playground slide. What type of surface is commonly observed in a playground slide? Rough or smooth? Okay, we always have a smooth surface in a playground slide. How does friction acting on such type of surface affect the movement of a child? So if we have a smooth surface, then we have less friction. And if we have less friction, that means a child's movement from the top of the slide going down is faster. So let's have the second picture. Okay, running shoes. So how does a pair of light rubber shoes help a runner run fast on a racetrack? So of course, if a runner is going to wear a light rubber shoes, then he can move faster. So you cannot see a runner using a leather shoes because it's heavier than a running shoes. Explain how friction between the shoe spikes and the ground affect the movement of the runner. So the spikes in the running shoes increases friction, so it is going to prevent the runner from sliding. Okay. Okay, we are now in the last activity, which is the assessment. So for the directions, it says here, encircle the letter of the correct answer. But for those who are advised to use a separate sheet of paper for your answers, please just choose the letter. Write the letter in your answer sheets. Okay, thank you, children. Good luck. Okay, so that's the end of our discussion for our Science Quarter 3 Module 1. Thank you.